So when we look at a reaction, after figuring out the oxidation numbers, we can determine what's happening with all of the components in the reaction. We're going to want to evaluate them all. In this equation, we have only hydrogen and oxygen, so we can go ahead and use those two elements. Let's see what happens to the hydrogen over the course of the reaction and what happens to the oxygen. It looks like the hydrogen is going from 0 to +1, and the oxygen is going from 0 to -2. And I'll try and make my zeros with these dashes through them so I distinguish from oxygen. We know that if these were ions, which they're not, if these were ions, going from neutral to +1 means that you've lost electrons. And remember that oxidation numbers are more ways of us accounting for electrons. They're not really describing losing and gaining necessarily, although they can. We're also, in molecules, we're looking at just kind of what's more likely to be holding the electrons, right? The more electronegative one will be more likely to be holding those electrons. So, and then in the reverse case, the oxygen has become more negative, therefore we can say it has kind of gained electrons, or electron density, we can say. And remember, we have words for this, right? We have our dear friend, the oil rig. Oxidation is losing electrons. Reduction is gaining electrons. Oil, oxidation is losing, OIL. Reduction is gaining, RIG, rig. That's how we can remember this. So if we have lost electrons, that is oxidation. And the process of gaining them would be reduction. So in this case, hydrogen has been oxidized. Oxygen has been reduced. And if we want to make ourselves more confused, we can throw in more vocabulary terms. For example, in order for oxygen to have gained electrons, it's going to have to take them from something. And that something is going to be what's lost the electrons, right? If oxygen is taking them, hydrogen must be losing them. Oxidation and reduction always go hand in hand. You can't have one without the other. And so if oxygen is taking the electrons away from hydrogen, hydrogen is being oxidized, and we can therefore call oxygen, the thing that is doing the oxidizing, the thing that is taking the electrons, the oxidizing agent. So we'll have our oxidizing agent. It oxidizes the other substance. So it's going to oxidize the other substance, and at the same time, it will be reduced. So, I mean, this is in kind of like English, right? We can say oxygen kicked hydrogen. Kind of violent. But we could also say hydrogen was kicked by oxygen, right? It's active versus passive voice, yes, but in either case, the sentences mean the same thing, right? So we could say oxygen oxidized hydrogen. We could also say oxygen was reduced by hydrogen. It's the same thing. And therefore, we can say if oxygen was reduced by hydrogen, because hydrogen gave its electrons, again, not really, but kind of, we'll say that we'll have also the reducing agent. In this case, it will be hydrogen. This one, just the opposite, reduces the other substance and is oxidized in the meantime. So your oxidizing agent does the oxidizing, and in the meantime, in that process of oxidizing something else, meaning it's taking electrons away, it will now gain electrons, right? It's removing electrons and gaining them. So it's removing electrons from something else and gaining them on itself. That's the oxidizing agent. It's the same thing as the substance that is reduced. So in this equation, we saw that oxygen is reduced. That means oxygen is the oxidizing agent. That's where the name comes from, by the way. Oxygen is a very common oxidizing agent. And on the other side, of course, the reducing agent is the one that will be oxidized, excuse me, because it's giving its electrons away. So it is losing them in the process of giving them away. And so it is the oxidized substance. In this equation, that would be hydrogen. And very importantly, agents, your oxidizing and reducing agents, must be reactants. So we can't just say H is our reducing agent, because in this chemical equation we don't have H anywhere. We have H2. So we want to find the substance of, that the hydrogen is part of. That's a reactant. And so that's going to be hydrogen. And on the other side, we have the oxygen, which will be our oxidizing agent. We don't say just oxygen. We have to say the reactant that contains the oxygen that is being reduced. So in that case, that's O2, oxygen gas. All right, so, we can look at this one more time. Another one. How about silver nitrate plus copper? Turns into copper 2 nitrate plus silver. Remember that all single replacements are redox, and we're going to use these a lot in electrochemistry. If we were to calculate the oxidation states of all of these, do it, pause the video. And now that we're back, perhaps, you should get the following. Ooh, that should be a plus. Silver is +1, nitrogen's +5, and oxygen is -2. Copper is 0, because it's by itself. We have copper is +2 now, +5, -2, and then 0. So these are the oxidation states you should get while doing them yourself. If we want to look at everything in this reaction, we see that silver starts as 1, turns into 0. That tells us right away it's a redox reaction, right? Anything changes oxidation state-wise, it's a redox reaction. Our nitrogen has gone from +5 to +5. Our oxygen has gone from -2 to -2. And our copper has gone from 0 to +2. So we see here silver has become more negative. We say that's reduced, right? Its number has gone down. We have reduced its oxidation state. And copper has therefore been oxidized. We can say, therefore, because silver is reduced, the reactant containing that silver is our oxidizing agent. And that's going to be our silver nitrate, the whole thing. Don't just, it's whatever your reactant is that has the compound or the element being reduced or oxidized. And then, of course, the copper is by itself, so we can say our reduction agent or our reducing agent is just Cu. And if we wanted to be like super good with this, we would, put states of matter and all that goodness and fun stuff. So within a reaction, we can identify the species being oxidized and reduced. We can identify the oxidizing agent and reducing agent as being the reactants that contain the ones that are oxidized and reduced. Remember that they switch names essentially for the agent. The reduced substance is your oxidizing agent, or part of your oxidizing agent. Your oxidized substance is part of your reducing agent. And as we see here, sometimes it's just the single element, like copper was, because that's how it shows up in our reaction. And sometimes it's a compound like with the silver here. Now, importantly, one more thing. If you have two instances of the same element on the same side of your reaction. So say you have, I'm going to just totally make up a reaction here. This is probably not something that will happen, but if we see here, I don't know, let's make this something else, copper minus, because why not? I'm just going to completely make up whatever I feel like. If you have two of them, let's say, gosh, I really have no clue what to do with this. Let's see if we can, yeah, there we go, why not? We'll make this completely bogus. We'll get positive 1/2. Remember, you can get fractions. This is totally something that's not normal. This is not a normal reaction. I'm just doing this to show y'all. If we look here, the nitrate's going to stay the same. We see copper has gone from +1 to 1/2, and it's also gone from 0 to 1/2. The +1 to 1/2 is being reduced. That number has decreased. The other one has increased, so that's oxidized. It can happen. You can have the same element be both oxidized and reduced. It's important when you identify the agent that you report the compound or reactant correctly. So if we see the copper that is +1 here is being reduced, that's our oxidizing agent. So our oxidizing agent is copper 1 nitrate. Our reducing agent, in this case, is just the copper. That's the one that's being oxidized, the one that's starting at 0. Whatever reactant has the copper that starts at 0, that's our reducing agent. So even if you have the same element, you have to find out, which oxidation state is for which compound and which is the one that's changing. So you just have to evaluate all these. It's not very common that we see these sort of reactions where we have the same thing, same element being oxidized or reduced, but it happens. Sometimes you'll also see multiple things being reduced and one thing oxidized, or vice versa. You can have as many of each as you want as long as you have one of each. You can have 2 oxidations and 2 reductions at the same time, 3 oxidations and 2 reductions, as long as you have at least one of each. And so it just depends on how complicated your reaction is. All right, so in our next video, we'll talk a little bit more now about actual electrochemistry.